are plenty of perfect settings tables on the internet, but if plasma cutting was that simple, you wouldn't be fighting draws, bad edges or missed pierces. Every machine is different. In this video I will explain which plasma settings actually matter, how they affect each other, and how to adjust them in real life. There are three main aspects of plasma cutting: cutting speed, arc current, and compressed air quality. Each one is as important as others, and you have to keep them all in mind when changing one of them. You cannot set the cutting speed based only on the thickness of the material. Arc current also has to be set correctly. First of all, we have arc current. This setting primarily defines if you will pierce the material at all. Let's start with what exactly is an arc current. A plasma arc is basically a superheated ionized gas, usually compressed air, reaching extreme temperatures. From the electric side, it has a voltage and current. Voltage depends on the length of the arc, and current is the parameter we set. The higher the current, the more powerful our arc is. To pierce or cut the material, you need a specific arc power. A weak arc will not be able to pierce the base material, but it doesn't mean the more powerful arc is the better. Too much power will cause the material to overheat, generate more draws and bigger curve, the width of cut. Now let's take a look at cutting speed. This parameter in short defines how the cutting edge looks like. A plasma arc is like a raging beast. It eats everything conductive in its path. The trick is to tame the beast and force it to do what we want. That's why the cutting speed is a very important parameter. If you are cutting too slow, the raging beast has too much material to eat, which makes the cutting edge uneven and overheated. Cutting too slowly also causes forming of excessive draws, because of the extra material which is being removed. If your cutting speed is too fast, most likely it will end up not cutting at all. Another sign of too high speed is an angle of the cut. The edge of the material should be somewhat vertical. Of course, it will be never perfectly vertical because of the nature of plasma cutting, but if the edge is extremely shifted, this means your cutting speed is too high. Last but not least, we have compressed air. This one is extremely important and usually overlooked by people. The compressed air has to be dry, free of oil, and has to have a stable pressure. You cannot expect constant cutting results when your compressed air is not constant. Bad air quality will lead to more draws and faster degradation of torch components. So in conclusion, the compressed air you use must be dry and needs to have a constant pressure. Let's now see how these factors work with each other. If you are increasing the arc current, you have to increase the speed. Your compressed air has to be a good quality because you will never get anything dialed in. If your torch is not piercing, your cutting speed doesn't really matter. Material must be pierced so you can take an arc current as a baseline for other settings. Unfortunately, there is no universal table where you can find perfect settings for your machine. Every machine is different, every plasma source is different. Start your testing with setting an arc current. Test whether it can even pierce the material. For example, my old cheap plasma source had troubles piercing 5mm mild steel at max current, which was 60 amps. My new plasma source, which is better and more expensive, has no troubles piercing 5mm mild steel at 45 amps. I'm pretty sure I could get even lower with current. For cutting speeds, my baseline is 1500 mm per minute. I start with this speed, cut my parts and check whether the cutting edge is not crooked, how much dross there is, etc. From this state, I first try to experiment with cutting speed. I will go a little faster and see what happens. If the results are better, I will go a little faster, until I'm happy with the cut quality. I try not to adjust the arc current too much. Once the pierce is achieved, you should adjust speed. More current is most likely not going to help with anything. That's everything for this video. If you have any suggestion what should I feature in the next one, feel free to leave a comment. Thank you for watching and I will see you in the next one.